Hello everyone, let's do analyze selection sort and try to solve any array using selection sort. So let me write first array. So 3, 5, 4, 8, 6 and 1. So this is the array. So what we're going to do is in this selection sort. So first of all, we will find a minimum element in this array. So we will check whether this is the minimum element. uh, Minimum element, we will check store the minimum element in a this variable. So we will check whether this is the minimum element or not. So firstly we will assign this as a minimum element. First element is our minimum element. Then we will check next node that this is the minimum element. So no, this is not our minimum element. Now we will check for this. So 4 is minimum element. So no, 4 is not a minimum element. Now we will check for 8. 8 is minimum element. So 8 is greater than 3. So it's not. Now check for 6. 6 is minimum element. No, 6 is also not a minimum element. Now we will check for 1. So 1 is minimum than 3. So what we're going to do is we will change this value as 1. And also in this min element, we will not store the value, but instead of value we will store the index. So if 0 1 2 3 4 and 5, so we will store the index 5. Okay, so over here we will store index 5, and then what we're going to do is we will swap the first value and the minimum index value. So after swapping, our array look like this. So 1 5 4 8 6 and 3. So after swapping, our array should look like this. So now what we're going to do is just 1 second. Now what we're going to do is let me rewrite over here. Now what we're going to do is now we will traverse through this array because this portion is sorted. One is it and is in its position. So one is so each and every step we will sort the array from left to right. Okay, now we will check a minimum element over here. So firstly we will assign first element as a minimum element. So our minimum element become 5. So now we will check for another element, 4. So 4 is less than 5, so we will assign minimum element as a 4. But instead of storing minimum element value, we will store the index. So for our minimum index is 2, so we will store 2. Now we will check for over here. So this is not a minimum, so we will check over here. This is also not minimum, we will check over here. So this is the less than 4, so we will change this value to 5. So we have minimum value elements over here. Now what we're going to do is we will swap with first element. So now we will swap these two values, and after swapping this value, our array should look like this: 4 8 6 and 5. Now we will again run our array, run our selection sort to remaining portion of array. So now let's run for initially our I is over here. So I 0 1 2. So initially 2 is our smallest value. So now we will check for 8. 8 is not smallest than 4. 6 is not smaller than 4. 5 is not smaller than 4. So we will just at the end we will just swap this value with this element. So and then we will just so there is no swapping happen over here. So our this portion is sorted. So now so this element is in its correct position. Now we will check for this portion of array. So first of all 0 1 2 3. So our I is pointing over here. So min element at 3. Now our pointer is move over here. So 6 is less than 8. So we will change to 4 min element index. Then this is 5. So 5 is also less than 6. So we will change it to 5. And now we will swap these two element. Okay, so after swapping, our array look like this: 4 5 6 and 8. Now we will check for these two values. So if we will assign first value as a minimum index, so this is 4. So now we will check for next value 8. So 6 is not less than 8. So and we reach to end of the array, so no swapping happen, and this is our sorted position, and now our array is sort. So this is how selection sort works. So its name suggests that we will select a smallest element and then we will swap with the first value. So what is the time complexity of the solving this problem? So initially we traverse through the overarray n time and we do this for n time. So total time complexity become n square, because first of all we are travel through over here to n time each and every element, and then we do this process for n time. So our time complexity become n into n equal to n square. Okay, so this is our time complexity, and space complexity is big of 1, and this time complexity for all the cases, best, worst and average test cases. So let's code this program. So let's write a code. So let me create a function, selection sort. Okay, this is the selection sort function which take n nums as input and return us nums. Okay, so let me just get input variable. So nums equal to list map int split. Okay, by this we getting input in nums, and then we will just print selection sort nums. Okay, so we will just printing our array. So now let's write a selection sort. So as you can see over here, we will starting from 0 index to end of the index. So we will just write for I in range of len of nums, and we will iterate to till last element, and in this for j in range of from I to len of nums. Okay, and over here we are finding a minimum index. So minimum index we are finding. So let me create a min index function which will initially pointing to our first element, and if uh, nums of min index value is greater than nums of I, nums of j, then we will just change our min index value equal to j. Okay, and at the end, for first iteration we will get the value of minimum index, in our case 1. So we will get the value of 1, so we will just swap it by nums of I, nums of min index equal to nums of min index and nums of I. So by using this we are swapping our values, and then we will just simply return nums. So let's run this code for any compilation error. So let's give it a input. Sorry. Okay, just giving a random input. So yes, we are getting a output in a sorted error. So thank you for watching this video.